Electrophilic substitution reaction. Generally, it is represented by this reaction. Some examples of electrophilic substitution reaction is: first one, halogenation. In halogenation, benzene reacts with chlorine in presence of AlCl3. Now this hydrogen is replaced by chlorine. Now if I continue this reaction, chlorination I mean, now in this case this chlorine is ortho and para directing group. Therefore, in ortho and para position, Cl will be dashed. These two products will be formed. Now in this case, para isomer is the major product. Now in the second type of electrophilic substitution reaction, which is nitration. Now I am taking chlorobenzene and it is reacted with concentrated HNO3 in presence of concentrated H2SO4 to form these products. Since again chlorine is an ortho and a para directing group, here also the para isomer is the major product. Now in the third example, which is sulfonation, in which chlorobenzene reacts with concentrated H2SO4 to form again this is O plus these products. In this case also this para isomer is the major product. Now after this sulfonation, we have two important named reactions, which are Friedel-Crafts alkylation and Friedel-Crafts acylation. Now in the fourth type, this is chlorobenzene. In Friedel-Crafts alkylation, we are taking this alkyl chloride in presence of AlCl3 and anhydrous aluminum chloride to form this plus I am taking another example of Friedel-Crafts alkylation, in which chlorobenzene is reacted with N-propyl chloride in presence of AlCl3. The expected product here is N-propyl benzene, but that is not the product here. The product, major product in this case, will be this isopropyl plus Here also actually this is a major product here. The reason for this change is, in this case, these two reagents or these two substances react to form an intermediate, which is this CH3 CH2 CH2 plus, which is a secondary carbocation, primary carbocation. So a rearrangement can take place to form a secondary carbocation by shifting this hydride ion to form a secondary carbocation, which is actually will look like this. So this will be the electrophile that attacks the ortho and the beta positions of this chlorine. Now these two reactions are Friedel-Crafts alkylation. Now in Friedel-Crafts acylation, this chloropenzene reacts with acetyl acyl chloride in presence of AlCl3. I'm just writing the major product here. This is 4-chloroestophenol. This reaction is Friedel-Crafts acylation, and these two reactions are Friedel-Crafts alkylation. Thank you guys.